Imagine a cat, a creature of grace and mystery, often seen lounging in the sun or curiously exploring its surroundings. Now imagine this cat trapped inside a box, not just any box, but one that holds the key to a profound scientific enigma. But this is no ordinary box. It's a thought experiment, a paradox designed to illustrate the strangeness of quantum mechanics, a realm where the rules of classical physics no longer apply. This is Schrödinger's cat. Proposed in 1935 by Erwin Schrödinger, this thought experiment challenges our understanding of reality. Schrödinger, a pioneer in quantum theory, used this paradox to question the nature of observation and measurement. At its heart lies the bizarre world of quantum mechanics, where things exist in multiple states at once. Particles can be in a superposition, existing in all possible states simultaneously until observed. Schrödinger's cat isn't just a scientific puzzle, it's a cultural icon, infiltrating everything from TV shows to philosophical debates. Its influence extends beyond the realm of physics, touching on themes of existence and consciousness. The cat's fate, a chilling superposition of life and death, forces us to confront fundamental questions. What is reality? How do our observations shape the world around us? These questions have sparked endless discussions and debates. Does observation shape the universe? Can the act of looking at something change its very nature? These are the mysteries that Schrödinger's cat compels us to ponder. The cat's meows, or lack thereof, echo through the halls of science and philosophy, urging us to explore the universe's most baffling mysteries. It reminds us that the quest for knowledge is never-ending, and that sometimes the questions are just as important as the answers. Let's open the box, metaphorically speaking, and examine the experiment. Inside the sealed box, we place a cat. Along with the cat, we introduce a tiny amount of radioactive material, a Geiger counter, and a vial of poison. Here's where quantum mechanics takes over. There's a 50% chance the radioactive material will decay. If it does, the Geiger counter triggers, smashing the vial and killing the cat. If the material doesn't decay, the cat remains alive. Sounds straightforward, right? Here's the catch. According to quantum mechanics, until we observe the cat, it exists in a state of superposition. This means the cat is both alive and dead simultaneously. Superposition is a cornerstone of quantum mechanics. It's a principle that defies our everyday experiences and challenges our understanding of reality. It states that particles can exist in multiple states at once until observed. This means that a particle can be in a state of being here and there, up and down, or even alive and dead, all at the same time. Imagine flipping a coin. Until it lands, it's both heads and tails simultaneously. This is a simple analogy to grasp the concept of superposition, but in the quantum world, the implications are far more profound. In our experiment, the cat's fate is tied to the radioactive atom. Schrödinger's cat is a thought experiment that illustrates the paradox of quantum superposition. The atom, like our coin, exists in a superposition of decayed and undecayed states. This means that the atom is both decayed and not decayed until we observe it. This uncertainty bleeds into the macroscopic world, placing the cat in its bizarre in-between state. The cat is both alive and dead until someone opens the box and observes it. It's important to remember that superposition isn't about our lack of knowledge. It's a fundamental aspect of how nature operates at the quantum level. It's not that we don't know if the cat is alive or dead, it's that the cat is both, simultaneously. This duality is a direct consequence of the superposition principle. This mind-bending concept challenges our classical understanding of reality. It forces us to rethink the nature of existence and the role of the observer in the quantum world. The implications of superposition extend beyond the realm of physics, touching on philosophy and the nature of consciousness itself. So what collapses this superposition and forces the cat into a single state? Observation. The act of observing the cat, of opening the box, forces the wave function to collapse. Think of it like this. The cat exists as a wave function, a mathematical description encompassing all possibilities. Observation acts like a measuring device, forcing the wave function to choose a single outcome. This brings us to one of the most debated aspects of quantum mechanics: the role of consciousness. Does consciousness itself cause the collapse, or is it simply an interaction with the quantum system? The answer remains elusive. Section 5, Copenhagen versus many worlds. Schrödinger's cat has sparked numerous interpretations, each attempting to make sense of the paradox. Two prominent interpretations are the Copenhagen interpretation and the many worlds interpretation. The Copenhagen interpretation, the most widely accepted, argues that observation causes the wave function to collapse into a single reality. But this raises questions about what constitutes observation and the role of consciousness. The many worlds interpretation, on the other hand, suggests that all possibilities occur. Every observation creates a new universe, a branching path where all outcomes exist somewhere in the multiverse. In one universe, the cat is alive. In another, it's dead. Section 6. Redefining reality. Schrödinger's cat isn't just a physics problem, it's a philosophical conundrum that has puzzled scientists and thinkers for decades. It forces us to re-evaluate our understanding of reality, pushing the boundaries of what we consider possible. If a cat can be both alive and dead, what does that say about the nature of existence? This paradox challenges our conventional wisdom and invites us to explore deeper truths. Does the universe exist independent of our observation? Or is it our act of observing that brings it into being? Or do we, as observers, play a fundamental role in shaping reality? This question has profound implications for our understanding of the cosmos. These questions blur the lines between observer and observed, challenging our perception of a fixed, objective universe. They suggest that reality might be more fluid and interconnected than we ever imagined. The thought experiment also raises questions about free will. If our choices are influenced by quantum events, do we truly have control over our destinies? If every quantum measurement creates a new universe with all possible outcomes, is free will an illusion? Or do we navigate through a multiverse of endless possibilities? Are we merely following predetermined paths laid out by the branching multiverse? Or do we have the power to shape our own reality through our choices and actions? These questions are not just academic, they touch on the very essence of what it means to be human. As we continue to explore the quantum realm, we may find answers that redefine our understanding of reality itself. In the end, the quest to redefine reality is a journey that challenges us to think beyond the limits of our current knowledge and to embrace the unknown. Section 7, Schrödinger's cat in our world. While the cat remains trapped in its hypothetical box, Schrödinger's thought experiment has had a real-world impact. It's a staple in popular culture, appearing in TV shows, books and movies. Beyond its pop culture presence, the paradox continues to influence scientific research. Quantum computers, for instance, rely on the principles of superposition and entanglement, pushing the boundaries of computation. The thought experiment also has implications for quantum biology. Researchers are exploring whether quantum effects might play a role in biological processes, from photosynthesis to bird navigation. Section 8, Unanswered Questions. Schrödinger's cat, despite being conceived decades ago, remains as relevant as ever. It's a reminder that the universe holds mysteries we've only just begun to explore. While we've made strides in understanding quantum mechanics, fundamental questions persist. What truly constitutes observation? Does the many worlds interpretation hold merit? The cat's fate, it seems, remains intertwined with the universe's deepest secrets. As we delve deeper into the quantum realm, one thing is certain: Schrödinger's cat will continue to challenge, provoke, and inspire us to unravel the enigmatic tapestry of reality.